Hello, and welcome to another episode of the CAINE Forensics video series. In this video, we are going to cover one of the most ubiquitous imaging tools out there, FTK Imager from Access Data. Please help me out by hitting the subscribe button below so I can run away from my abandonment issues. FTK Imager is a free tool that can help you acquire forensics data off computer media. The tool allows you to create forensic images. You can perform logical acquisitions of files and folders. You can obtain protected files. You can generate directory listings. You can perform a memory capture. You can preview the contents of captured forensic images. You can mount an image for read-only view. You can export files and folders from forensic images. You can see and recover deleted files. You can hash files with the MD5 and SHA1 algorithms. And you can capture and view APFS images for Mac computers. Wow, that's a lot of functionality. So let's break it down into common tasks you may use it for. But before that, let's talk about the two vastly different situations where you may use FTK Imager. The first scenario is that you are at your lab and someone hands you a media item like a hard drive or a USB thumb drive, and your job is to image it. This is where you will be running FTK Imager from your forensic workstation, and you're going to be connecting the media items to that forensic workstation via hardware write blockers. The executable of FTK Imager will more than likely be already installed on your forensic workstation. The second scenario is that you are either in the field or at your lab and you are tasked to obtain the image of a live running computer. In this case, you would be running FTK Imager off a USB drive and then saving the results either onto that same USB drive or another staging drive. Let's look at the first scenario where you are running FTK Imager off your forensic workstation. You can see the link below for where to download the executable from Access Data. Because we're using the CAINE distro, it's already built in to the disk. Once we open the program, let's go over the interface. You will see the menu items up on top, then the taskbar, which is basically the icon version of the commonly used item off the menu. Then there are 4 panes consisting of the evidence tree, the file list, the viewer, and properties. The evidence tree will be the big picture of what items you are looking at. Any selected items there will populate the file list pane, and any items selected in the file list pane will populate the viewer pane and the properties pane. For our first task, we are going to be imaging a thumb drive. Before inserting the thumb drive into the system, let's look at the disk manager to see what's currently there. Here we see that my system already has disk 0 and disk 1, which are the 2 internal hard drives. Plug in the target media via a hardware write blocker if possible. Looking at the disk manager again, you may need to hit refresh. We now see that the system has a new disk, the 16 gig USB. Then we would plug in the destination media. And again, looking at the disk manager and possibly hitting refresh, now you see another disk, a 1 terabyte, which is going to be our destination media. And if your system is set to not auto mount, then you need to use Disk Manager to assign a drive letter to the destination drive. Do not assign a drive letter to the evidence. You never want to mount the evidence. Because we're interested in imaging the USB thumb drive, we can click on the icon for Create Disk Image, or else hit the File, Create Disk Image in the menu. But I'm going to cancel it, and I'll tell you why. Unless you are in a super hurry, it may be better for you in the long run to actually add the evidence item first by clicking on the Add Evidence Item icon or clicking on the File menu and then Add Evidence Item. From here, you can go ahead and select the physical drive, which is your USB, then finish. So the reason why I like to add the evidence item first is that I can get a quick preview of the evidence to see if it's encrypted. If the media is encrypted and you don't have the passphrase, it may be a waste of your time to image this item. Or you may want to lower its priority and image something else that is not encrypted first. Once I have determined that I indeed want to image this item, I can right-click in the evidence tree on the physical drive for my thumb drive and then select Export Disk Image. The pop-up panel will ask you for the image destination. Click the Add button and select the destination image type. I recommend either RAW, which is DD, or E01. Next, you can type in the case number, the evidence number, and other information about your case. After that, you will be asked for the destination folder. Click Browse and choose your destination media. Then add in the base name for your image. I recommend using the unique evidence numbering used by your laboratory. You can change the image fragment size from 1500. My lab has historically used 2000 megs, so I will stick with that. For compression, I have found no significant difference, so I will leave it as the default of 6. And lastly, depending on your lab policy, you can choose to encrypt your image. I'm not going to. After you hit finish, we are back at the Create Image panel. You can leave the default setting of verify images after creation. I think this is a good idea to verify, so I'm going to leave it checked. And I usually like to select the pre-calculate progress stats, so I have some idea of how long the process will take. Lastly, you can have the tool generate a directory listing if you want, or if your lab policy requires it. I'm going to check it so you can see the output. Now you can hit start. Here you see the progress bar on top telling you the percentage until done. You are reminded of the source and destination, and then the amount of data processed and amount to be done with the estimate time left. Once it's done with imaging, you can see that it's going back and reading the image from the destination drive and comparing the hash of the written data versus the hash of the data read from the original evidence. The verification is usually faster as it's quicker to read from a disk than to write from a disk. Plus, since we used compression, there is less data to be read back. I'm going to click on the image summary to see the results. This will give you the version of the tool, all the metadata you typed in, the drive geometry, the drive info, and computed hash. It also has the imaging start and end timestamps and the verification timestamps. We can close this out, and I just want to note that this is information that's useful, and it's also in the text file that has the same name as the image, just with the .txt extension appended to it. So if we go out to the File Explorer window and open the text file, you can see that this is the log. Also note the CSV file, the comma separated value file that is here, which is the file listing that we requested. For the second task that we will run on our forensic workstation would be the case where someone else had created an image of some media and they handed it off to us for analysis. The first thing I would do is to verify that the image is still intact. To do that, click on the Add Evidence Item icon, then Image File, and then select the image file. Once the image file has been read in, right-click on the top level of the image and select Verify Drive/Image. This will kick off the verification process, resulting with a pop-up panel which will show you the MD5 and SHA1 hashes and whether the verification matched. And if you look at the text file that was there, you will also see that the latest verification stats of timestamps have been appended to that file. This image verification procedure is also very helpful when you are doing a post-examination verification. This is part of the standard operating procedures for most laboratories, but even if it's not, it's a very good idea to perform a post-exam hash of your evidence to ensure that there were no changes to the image. For the third task that we will run on our forensic workstation is that of mounting an image. Why would you do this? There are several tools that doesn't know how to read an image file, so if you mount it first with FTK Imager, then the tool can process the mounted device or physical device. To do this, click the Add Evidence item, then right-click on the top level of the device and select Image Mounting. A panel will come up that will ask you for the mount type of physical only, logical only, or both. A physical only will create a device that would look just like a physical device connected to the computer. And a logical only will create a logical device that would only be accessible via a drive letter. Your selection will depend on what you want to do with the mounted image. For this demo, I'm going to select the logical only. Next, you can select the drive letter. I'm going to select Q. Lastly, you will be asked for the mount method with choices of block device with read-only or read-write, and then file system, which is read-only. If you select the writable version, you can select a cache file folder that will store the cache of your changes. I will choose the file system read-only for our demo. Once you click on Mount, FTK Imager will generate a logical drive as you requested. And you can see the logical drive from the File Explorer under the drive letter Q. When done with the mounted images, click Unmount for each of the mapped partitions, or hold down the Control key to select multiple mapped partitions. Another thing that FTK Imager helps you with is obtaining the drive information. Information such as make, model, serial number, the number of partitions, and what their file systems are all items that should be included in your report. With FTK Imager, you can find out the partitioning scheme used for that device. You can see how many partitions there are and what file systems are on each of those partitions. To see these properties, click on the evidence item in the evidence tree to select that device, and then click on the Properties tab on the bottom left. You can see the make, model, serial number, and all the other details. And as you select a different partition in the evidence tree, you can see different information being reflected in the Properties pane. One of the most useful functions in FTK Imager is the memory capture feature. In incident response, it is critical that we capture the memory of the running system. This is because there could be passwords and credentials within memory. The network connections are captured in there, running processes, programs that are only resident memory, such as certain viruses, unsaved files. So all kinds of very important things are in memory. So how do we capture memory with FTK Imager? You basically can click on the capture memory icon, which looks like a memory stick. Or if you just go under the file menu, you can also select the capture memory option. First thing it's going to ask you is to browse to a destination path. So go ahead and select that. And then you're going to give a name to the memory capture. I would advise using the evidence number, so it's a unique name. Otherwise, by default, it's going to be called memdump.mem. You don't want to have 5 memory dumps with the same name. You want to identify them uniquely by your evidence number. Next, you have the option to include the page file. So the page file is an extension of memory, so it's also very important. So I would recommend that you include your page file. And lastly, you have the option to create a AD1 container to store the memory and page file. So I do like the idea of containers because it has hashes and whatnot, but the AD1 takes a significant amount of time. So if you are under time constraints, I would recommend you not do the AD1 container. You can always just hash the memory files by themselves later. Once you select capture memory, it will take some time to do. Good thing is that there is a status bar letting you know how much time it's going to take. And when it's done, let's go and take a look at what files are generated. So out in the file browser, we see here that there is a AD1 that it created and a AD1.txt, which contains the log and hashes and so forth. Another function that you may use on a live capture is the Obtain System Files feature. This will copy files that otherwise would be locked down by the system. So if you click on the Obtain System Files icon, you'll be presented with a pop-up panel that will ask you for the location for storage. So go ahead and browse to a folder where you want to save the files. Your next choice is to select to either only include the minimum files or password recovery and all registry files. So the minimum basically will just give you the SAM and system registry hives, and then the RSA keys for your crypto and protected folders. The all registry will give you the SAM, the security, software, and system hives, in addition to the NT user DAT for every user. So we go ahead and select what we need and click OK. When it's done, we can take a look at what we have. So from the File Explorer, we can see that it captured the default hives, the SAM, the security, the software, system, etc. It has also captured the crypto keys for your RSA keys and so forth. Another feature of FTK Imager is the ability to create custom content images. Basically, these are image files which contain logical files. So the way to create one of these is if you go and select files of interest. Let's say we want to capture the hyperfill.sys and the pagefile.sys files. So we go ahead and select those and then right click. And we're going to click on the Add to Custom Content Image. And let's say we're going to look around at other files that we are interested in capturing. So for example, this download folder. So once again, we can right click and select Add to Custom Content Images. Let's go ahead and select another file. Let's just get the whole desktop, add that to the AD1. And when you're ready, we can click on the bottom here, which says Create Image. It's going to pop up a panel. We're going to go ahead and add the information for case number, evidence number, etc. And then we want to select a destination folder for the AD1 image. And we also want to select a file name. So once again, I encourage you using your unique identifiers. Once again, you're going to set the image fragment size, compression size, encryption, and all that. I'm going to leave all those as the default. And similarly, we get to choose between verifying the images, which we want, pre-calculate progress status, which we also want, so we know how long this might take. And then lastly, for creating a directory listing, we're going to uncheck that because we don't need a directory listing. Once you hit start, it is going to go ahead and grab all of the files that we had selected and copy those out. Then it's going to verify when it's done creating an AD1. Or if you have multiple files, it's easier to hash the entire container versus hashing every single file inside and then comparing those hashes. We take a look at the image summary. It tells you what it did, right? It lists out all the files that it put into there and the dates and times of the creation and verification. And once we're done, we can take a look at the 81 container by doing a add image. Then we're going to go ahead and select the 81 container that we had just created. And then we can expand the image out. And as you can see, it preserved all of the file structure. So if we take a look at the root of the file system, we see that we had selected the hyperfill.sys and pagefile.sys files. And then under the user informant, we had extracted the desktop and download folders. So those are all logically copied out. And when you're done looking at the 81, you can go ahead and click on Remove Evidence Item. Alright, so that brings us to the end of this video where we took a look at FTK Imager, which can help you image media using an install version of the program or perform live capture when using FTK Imager Lite off a thumb drive or other portable media. Hope you enjoyed it, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.